So in the previous classes we have learned how to calculate the rotation contributions, but in sway analysis we have to consider one more value, that is displacement contributions. A frame may undergo lateral sway depending on few factors. So one such factor may be due to asymmetric framing, and it may be due to the asymmetric support conditions, and also it may be due to the asymmetric loading. Hello everyone, welcome to Civil Galaxy. Myself Dr. Pruthviraj B S. In today's session we shall see how to analyze a frame when it is subjected to the lateral sway. So in previous classes we have learned how to analyze a frame when it is symmetric and without the lateral sway. So here today we shall learn how to analyze a frame when it is subjected to the lateral sway. So a frame may undergo lateral sway depending on few factors. So one such factor may be due to asymmetric framing, and it may be due to the asymmetric support conditions, and also it may be due to the asymmetric loading. So to illustrate this one with an example over here, if you are having a frame and suppose this frame is subjected to a lateral load over here, say P, then this particular frame undergoes a lateral displacement over here in this way, and this lateral displacement can be called as delta. So this can be called as delta over here. So now if you observe, due to this lateral load over here, we are getting an additional moment at this place in the column. At the top we are getting an additional moment, also at the bottom of the column we are getting an additional moment. Here also at the top we are getting an additional moment, at the bottom we are getting an additional moment in the column. And we have to remember that the additional moment is created only in the columns and not in the beams over here. So this additional moment, whatever we are getting, this additional moment we can call this as an displacement contributions. Displacement contributions. So in the previous classes we have learned how to calculate the rotation contributions, but in sway analysis we have to consider one more value, that is displacement contributions. So the sway analysis in the Kanis method of frame can be studied under two cases. So let us consider first case. For example, when the frame is subjected to lateral sway due to vertical loads. Due to vertical loads. See here, if I consider a frame over here, see here, this is A, this is B, this is C, D, E, F, G, H, I, J, K, and this is L. So now if I consider this column BC over here, say this column I am considering here, this is B and this is C over here. This column BC I have taken it outside, and suppose if this column is subjected to a lateral load over here, say H. Here also we are having an opposite reaction. So whenever this column is subjected to an additional or external force over here, we are getting an additional moment like this about the column. So this we will represent it as M double dash CB. That means the displacement contributions from C to B, and this we can denote it as M double dash BC, which means the displacement contributions from B to C. see here this moment is acting at the top of the column. So M double dash CB is at the top and M double dash BC here is it at the bottom over here, and this is the total height of the column. So now if we want to find out the value of H over here, if we apply the equilibrium conditions about this point B over here, we are having a value of H is equal to negative. So here it will be M double dash CB, M double dash CB plus M double dash BC upon the total height. So this is the formula we are going to get. So now similarly, if you want to find out the value of all the columns over here, this particular formula can be rewritten as summation of H is equal to negative summation of displacement contribution. See here, this is M double dash CB over here. That means the displacement contributions at the top. So this CB will be represented as T because the displacement contributions at the top plus summation of displacement contributions about the bottom upon the total height of the story, which is represented by HS. So now, apart from finding out the total value, what we need to find out here is we need to find out the displacement contributions. So to find out the displacement contributions, first we need to find out the displacement factor. So in previous classes we have learned how to find out the rotation factor, but whenever a frame is subjected to a lateral sway, here we are getting an additional value, that is displacement contribution. So before calculating the displacement contributions, we have to calculate the displacement factors, that is displacement factor, which is represented by U dash. We know the rotation factor is represented by U is equal to 0.5 into K by sigma K. But here displacement factor is represented by U dash is equal to minus 1.5 into K upon sigma K. So this is the formula we need to use to finding out the displacement factor. Now if you want to find out the displacement contributions, so the displacement contributions, so the displacement contributions is given by M double dash is equal to, we know the formula for rotation contributions, which is given by M dash is equal to U into summation of the fixed end moment plus summation of far end rotation contributions. But here we are finding out the displacement contributions, which is M double dash is equal to the the displacement factor, that is U dash into this formula over here, that is sigma M double dash top plus sigma M double dash at the bottom. So this formula we need to use whenever we are calculating the displacement contributions. So if we take the second case over here, that is sway due to vertical and horizontal loading. If here, for example, this frame is subjected to a lateral load over here, then we are having a moment over here like this. So that means we need to find out the story shear also. So from the case 1 we learned how to find out the displacement contributions. So whenever a frame is subjected to the lateral sway due to vertical and horizontal load, here the value of H, for example this is H over here, then the value of the H, that is sigma H, we have got it as minus summation of M double dash T plus summation of M double dash B upon the height of the story. This remains same, and the displacement factor also remains same, that is minus 1.5 into K upon sigma K. So this displacement factor is denoted by U dash. And next, if you want to find out the displacement contributions over here, which is represented by M double dash, that is displacement contributions. So this can be represented as, here we need to find out the story shear also due to the lateral loading over here. So here the formula will be SR HS upon 3, where SR is the story shear and HS is the height of the story, divided by 3, plus summation of M double dash T plus sigma M double dash D. So this is the formula we need to use to find out the displacement contributions whenever the frame is subjected to a lateral sway due to vertical and horizontal loading. So here I have considered a frame, and we shall see how to analyze this particular frame when it is subjected to the lateral loading with the help of Kanis method. So if you observe over here, the height of the column AB is 4 meters and the height of the column CD is 4 meters, and the length of the beam BC is given as 4 meters, and at point B it is having a lateral load of 20 kilonewton. So from previous classes we have learned that the first step in the Kanis method will be to find out the fixed end moment. To calculate the fixed end moments. See, if you observe over here, there is no loading on column AB over here, there is no loading on column CD over here, and there is no loading about the beam BC also. So the fixed moment from A to B, the fixed moment from B to A, also the fixed moment from B to C, and fixed moment from C to B, and the fixed moment from C to D, and the fixed moment from D to C will be equal to 0, since there is no loading on the frame over here. So after finding out the fixed end moment, the second step in the Kanis method will be to find out the relative stiffness, which is represented by K, and to find out the rotation contributions, represented by U. So now from the previous classes we know whenever we need to find out the stiffness and the rotation contribution, we need to consider an table which includes the joints. For that particular joints we need to consider the members, and for that particular member, whatever we have considered, for that particular member we need to find out the stiffness, that is represented by K, and then we have to consider the total stiffness, which is represented by sigma K, and in the last we need to find out the rotation factor, which is represented by U is equal to minus half into K upon sigma K. So this is the table we are considering in the second step to find out the stiffness and rotation contributions. So if we see over here, we are having two joints over here, B and C, and for joint B we are having two members, B to A, B to C, and from C we are having two members, C to B and C to D. So we are having two joints over here. Say this is joint B. So we are having two members, B to A as well as from B to C. If we take the joint C over here, we are having two members, C to B as well as C to D. So now if you want to find out the stiffness, we know that we have to consider the far end conditions. For member BA, B is the near end and A is the far end. Since the far end is fixed over here, the stiffness will be equal to I upon L. So the length of the column here they have provided, that is I upon 4, which will be 0.25 I. So this is the value we are going to get. Now for BC, if we consider B is the near end and C is the far end, since the far end is an intermediate support over here, intermediate support also is considered as an fixed support. So the stiffness value will be equal to I upon L. So this will be equal to I by 4, which is 0.25 I. So for CB, if you take here, C is the near end and B is the far end. The far end is intermediate support over here. So it is considered as a fixed support. So the value will be I upon L, which is I upon 4, 0.25 I. So for member CD, C is the near end and D is the far end, and the far end is fixed over here. So it will be I upon L, which will be equal to I upon 4.25 I. So now we have to take the summation of these two members about joint B over here. So 0.25 I plus 0.25 I, we are getting a value of 0.5 I. Here also 0.25 I plus 0.25 I. Sorry. We are having a value of 0.5 I. So now if you want to find out the value of the rotation factor U over here, just we will apply the value K and sigma K over here for each member. So the value of rotation factor for member BA will be equal to minus 0.25. For member BC, it will be minus 0.25. And for CB member, it is minus 0.25. And for CD, this will be equal to minus 0.25. So this is the values. So after finding out the stiffness and rotation factors, since we are analyzing a frame which is subjected to a lateral sway, we have to consider one more table over here. In step 3, we need to consider one more table to find out the displacement contributions. To find out the displacement, we have to find out the displacement factors, not displacement contributions. After finding out the displacement factors, then we will calculate the displacement contributions with the help of the Kanis table. So to find out the displacement factors, we have to see how many stories we are having over here. This is a single bay and a single story over here. So in the first, we have to use one more table over here where I will consider story. We are having one story over here, and for that particular story, how many members we are having, we need to see. See, here we are having two members, B to A and C to D. So we are having two members for that particular story. So we will take members, that is B to A and C to D. So now for that particular member, we need to find out the stiffness. We need to find out the stiffness, which is represented by K. And we know whenever we need to find out the stiffness, we need to consider the far end conditions. B is the near end and A is the far end. Since A is fixed over here, we are having a value of I upon L, which is I by 4, which will be equal to 0.25 I over here. So similarly, C is near end and D is far end. Since the far end is fixed over here, the stiffness will be equal to I upon L, which will be equal to I upon 4. This is 0.25 I over here. So after finding out the stiffness, we need to find out the total stiffness about the story, about this story, which we are having only one story. So 0.25 I plus 0.25 I, which will be equal to 0.5 I. So now after finding out sigma K, we need to find out the displacement factor, which is represented by U dash. So here U dash is equal to minus 1.5 into K upon sigma K. So just if we add the value K and sigma K over here, we are going to get the displacement factor for member BA and member CD. So we are having, if you put the value of k is 0.25 and sigma k 0.5i, we are having a value of minus 0.75, and here also we are having the same values, that is minus 0.25 and 0.5. So if we apply the value over here, we are getting minus 0.75. So after finding out the displacement factor, next we need to find out the story moment. See here, since we are having a lateral load of 20 kilonewton over here, which is coming from left to the right side direction, so the opposite moment also, so the opposite force also will be in this direction, that is from right to left. This will be 20 kilonewton. Since it is coming from right to left, we will take it as positive. So if I want to find out the story moment, so the story moment which is given by the formula SR HS upon 3. So now if we see over here, the story shear, what is the story shear here? We are having 20 kilonewton. So it is coming from right to left, the reaction. So we are taking it as positive. So it will be plus 20 into HS, that is the height of the story. Height of the story over here is 4 meters divided by 3. See here, since the lateral load is acting only on the member BA over here, we need not consider the member CD. We will take only one member into consideration. So the story shear here is 20 and the height of the story here is 4 meters divided by 3. So the story moment will be equal to 26.67 kilonewton meters. So this is the value. So the next step will be to calculate the rotation contributions and the displacement contributions. So for that I have considered a table over here, which is also called as the Kanis table, where we have represented or just replaced the intermediate supports with the help of boxes over here. So the next step here, which is step 4. So the step 4 will be to calculate the rotation contributions and displacement contributions through the iteration process. So what we have to do in this Kanis table over here is that we have to represent the fixed end moments whatever we have got in the first step. Also we need to represent the rotation contributions whatever we have got. Also we need to represent the displacement factors what we have got in the third step over here in this particular table. So if we take just here, this is point A, this is B as per the problem, this is C and this is D over here. So if we represent the fixed end moment whatever we have calculated in the first step, the fixed end moment from A to B, the total fixed end moment about all members were 0. So here also it will be from B to A 0, from B to C it is 0, from C to B it is 0, C to D it is 0, and D to C also it is 0 over here. So now after representing the fixed end moment, we need to represent the rotation contributions whatever we have got in the first step. So the rotation contributions from B to A and from B to C, we had got a value of minus 0.25. Here also we had got a value of minus 0.25, and from C to D we had a value of minus 0.25, and from C to B we had a value of minus 0.25. So after representing this one, inside this particular box we have to write the summation of the fixed end moment. Since the fixed end moment are 0 about all the members over here, the summation of fixed end moment also will be equal to 0 over here. We can see here. Now we have to represent the displacement factor, whatever we have calculated in the third step. So the displacement factor, we had got a value of minus 0.75, that is from member B to A. So we had got a value of, here, right, this is right here, minus 0.75. Here from C to B we had got a value of minus 0.75. So now next what we have to do here is we need to represent the rotation contributions, which is represented by, we need to find out the rotation contributions, that is m dash AB, and here we need to calculate m dash BA, and at joint B we need to consider m dash BC. So at joint C we will be getting m dash C to B, and from C to D we are getting m dash C to D, and here m dash DC. So since we know that the rotation contributions are only calculated for the intermediate supports and not for the end supports, so the rotation contribution, that is m dash AB, will be equal to 0 over here, and here also m dash DC, this will be equal to 0. Also, since we are calculating or analyzing a portal frame which is subjected to the lateral sway, we need to consider the displacement contributions, which is represented by m double dash. So here we need to calculate m double dash B to A, because we are having single story, we have calculated for member B to A. This will be m double dash BA, and here this will be equal to m double dash C to D. So the displacement contributions also need to be calculated. So first we shall go for the first cycle. We shall see how to calculate the rotation contributions and rotation and displacement contributions. So in the iteration process, if we go for the first cycle over here, see here, we know that whenever we need to calculate the rotation contributions, that is m dash BA is equal to, we know the formula, that is U into summation of fixed end moment plus summation of far end rotation contributions. This is the formula to find out the rotation contributions. So m dash BA, here it will be equal to, what is the value of U here? So the value of U for BA we have taken, that is minus 0.25. Summation of fixed end moment here, it is 0, plus summation of far end rotation contributions. So for B to A, which is the far end here, m dash AB, it is 0, and here m dash CB, we don't know the value for the first cycle, so we will take it as 0 over here. So we are getting a value of 0 for the first one. So similarly for m dash BC, the rotation factor remains same, fixed end moment also remains same, everything else also remains same. So this will also be equal to 0. So now these two values we will write over here, that is m dash BA. See here, m dash BA, we have got a value of how much here? First value is 0, here also this is 0. So now next, if you want to calculate for m dash CB, so see here m dash CB, the rotation factor here also is minus 0.25. Summation of fixed end moment, here also it is 0, and the far end rotation contributions are also 0. So this also will be equal to 0 over here. So next, if we calculate for m dash C to D, since it is having the same rotation factor, the values also will be same. So the first cycle will be equal to 0 over here. So we are getting a value of 0 for the rotation contributions. Here we can see m dash CB also is 0, and m dash CD also here is 0. So now, apart from calculating the rotation contributions, we are having another additional two values to find out the displacement contributions. So in the cycle 1, we need to find out the displacement contributions. The displacement contributions. So to find out the displacement contributions, we know the formula, that is m double dash is equal to u dash into SRHS upon 3 plus sigma m double dash top plus sigma m double dash bottom. So this is the formula we need to use to find out the displacement contributions. So now if I want to find out the value of m double dash BA, so m double dash BA, here we see that is the u dash is represented by the displacement factor. So the displacement factor, we have got a value here, m dash BA, which is minus 0.75, and the value of this story height, whatever we have got, how much we have got here, it is 26.67, which is 26.67 plus, here if you see, that is sigma m double dash T, that is we have to consider the rotation contributions, whatever we have got here we have got a value of 0 plus the displacement contributions at the end will always remain 0. So this is equal to 0. So this we get a value of minus 20 kilonewton meters. So this value we will just add over here. We are getting a value of how much? We'll write here. That is minus 20. So similarly, if we come this side also, since we are having the same displacement factor value, if we apply m double dash CD, it will be equal to minus 0.75 into 26.67 plus 0 plus 0. This also will be equal to minus 20 kilonewton meters. So this will be equal to here minus 20. So now what we will do here is we will go on calculating the rotation contributions and displacement contributions until unless we are getting the same and equal values. So for that we can just go for second cycle. Everything remains the same. See here, only the rotation contributions about the far end keeps on changing over here. Here also. So rest everything will remain as it is. So now if we go for the second cycle over here, see m dash BA, if you want m dash BA over here, this is the summation of fixed end moment plus the summation of far end rotation contributions. Now what is the summation of far end rotation contribution? Here we have got a new value, that is minus 20. Here we have got a new iteration value minus 20, but here the far end rotation contribution still here is same. So this will give a value of 5 kilonewton meters. Similarly here also if we take, it will be same value, minus 20 plus 0, this will be equal to 5 kilonewton meters. So this value we will just add over here, that is 5, here also it is 5. So now if we take here, this is the summation of fixed end moment is 0. Here we are getting a new iteration value, that is minus 20, and here also we are getting a new iteration value about the far end, that is plus 5 and minus 20. So this will be equal to, so this will be equal to 3.75 kilonewton meters. So here also the same value we can apply, minus 20. So this will be equal to 3.75 kilonewton meters. So this value we will add over here, that is 3.75, here also 3.75. So now if we come for the displacement contributions, about the top, what we are having about the top over here, if you see here we are having a new iteration value, that is plus 5, and about the bottom is always 0. So we are having a value of minus 26.56. So minus 26.56 kilonewton meters. So here also the same values are applicable. Plus 5 plus 0, this will be equal to minus 26.56 kilonewton meters. So this value will just add over here. That is minus 26.56. Here also it is minus 26.56. So if we go for the third cycle, so just if you go for the third cycle, see here. So here M dash BA, the far end rotation contributions, here we have got a new value, that is minus 26.56, and here we have got a new value, that is plus 3.75. So this will be equal to 5.70 kilonewton meters. So this value will apply over here, that is 5.70. So similarly, here also the values will be same, minus 26.56 plus 3.75, 5.70. So here also we will get a value of 5.70. So now here the far end rotation contributions, here we have got a new value, that is plus 5.70, and here a new value which is minus 26.56. We are getting a value of 5.22. So here also it will be same, which is 5.22. So here we can take it as 5.22. Here also it is 5.22. So now if you want to find out the displacement contributions for the, this is the third cycle, sorry, this is third cycle. So this also will be the third cycle. So if you want to calculate the displacement contributions, see here. So the displacement contributions, here we are having a new value which is plus 5.70 plus 0. This will be equal to a value of minus 28.19. So this value will write over here, minus 28.19. So here also we are getting the same value, which is minus 28.19. So this value about M double dash CD will write over here, that is minus 28.19 kilonewton meters. So next if we go for the fourth cycle, see here. See here. So here if you want to calculate M dash BA, we are having the new value over here, which is minus 28.19 plus the new iteration value about M dash CB is 5.22. So we are having a value of 5.73. So 5.73. So we will take it as 5.73 over here. So now here also the values will be same, 28.19 plus 5.22. Here it is 5.73. So M dash CB, if we take M dash CB, we are having a new iteration value over here, which is 5.73. So this value will write over here first, 5.73. So 5.73 is the new iteration value over here, and also we are having a new iteration value about this point over here, which is minus 28.19. So we are having a value of 5.61. 5.61. Here also it will be same, 5.73 minus 28.19, which will be equal to 5.61. So these two values we will just write over here, 5.61 and 5.61. So now if you want to find out the displacement contributions, here also if you take m dash BA, we are having a new value over here, which is 5.73 plus 0. Here also 5.73 plus 0. So we are having a value of minus, so this is the fourth cycle, sorry, forgot to mention, value of minus 28.32, minus 28.32, here also minus 28.32. So this value we will write over here, minus 28.32. So here also minus 28.32. So we can just observe over here the values are slightly same, but here we can see there is lot of difference over here. So probably if we go for the fifth cycle, we will see we will get the same values or what. So just remove the far and rotation contributions, whatever we have considered here, and here also rest everything remains same. See here. So this is m dash BA. About m dash BA, the new value here is minus 28.32 plus m dash CB, the far and rotation contributions here should be equal to plus 5.61. So we are having a value of 5. So this is probably the fifth cycle here, the fifth cycle. So this will be equal to 5.73 again. So this is 28.32 plus 5.61, which will be equal to 5.73. So this value will write over here, 5.73 and 5.73 over here. So now if we take m dash CB, a new iteration value is over here, 5.73 minus the new iteration value, which is 28.32. So we'll get a value of 5.69. So here 5.69, here also it will be 5.69, because since the values will be same over here, it is 5.69. So now if we take m double dash BA over here, the new iteration value we are getting as plus 5.73 plus 0 plus 5.73 plus 0. This will be equal to, here we are having a value of minus 28.57, minus 28.57, here also minus 28.57. So this value we will write over here, minus 28.57. Here also it is minus 28.57. So almost the values are similar over here. Here there is light of difference, and here also there is light of difference. So probably we will go for the sixth cycle over here, and we shall see whether we are getting a similar values or not. So this we will just remove the part. Rest everything remains same. So here the sixth cycle, in the sixth cycle, to find out the rotation contributions, here minus, and here we are getting a new value, that is minus 28.57 plus here a new iteration value, that is 5.69, which will be equal to, so 5.72. So we are getting a value of 5.72, 28.57 plus 5.69, which will be equal to 5.72. So these two values will write over here. For m dash BA it is 5.72, here also it is 5.72. So for m dash CB, here a new iteration value which is 5.72, and here minus 28.57, we are having a value, we get a value of, so 5.71. So this value we will write over here. So this will also be same, 5.72 minus 28.57, which will be equal to 5.71. So this value we'll just put over here. Now if you want to find out the displacement contributions for the sixth cycle, see here, for the sixth cycle, here we are having a new value, that is plus 5.72 plus 0 plus 5.72 plus 0. So we get a value of minus 28.57 minus 28.57, and here also minus 28.57. So this value we will add over here. So here also it is minus 28.57. So see here, now the values are almost similar over here. So if we go for the next cycle, we are going to get the same values. So let me consider this value as the final value to calculate the final end moments. So here and this one, and here this one, we'll calculate as the values for the final end moments. So the last step here will be to find out the final end moments. So if we want to find out the final end moments from A to B, we know the formula, that is MF AB plus 2 times the rotation contribution about the near end plus 1 times rotation contribution about the far end plus the the displacement contributions. Since we are going for an sway analysis, we have to consider this additional value also. So the fixed moment from A to B, we know it is 0. About the near end also it is 0. And we are having the new value over here, that is 5.72. About the far end, we have considered this value, and also the displacement contribution, that is minus 28.57. So now the moment about point A to B will be equal to minus 22.86 kilonewton meters. So similarly, now we have calculated I have calculated all the values. I will just go on writing here. So final end moment from B to A will be equal to minus 17.14 kilonewton meters. So final moment from B to C will be equal to plus 17.14 kilonewton meters, and moment from C to B will be equal to minus 17.14 kilonewton meters, and the moment from B to C to B also here is plus 17.14. Moment about C to D here is minus 17.14 kilonewton meter, and moment from D to C, we are having a value of minus 22.86 kilonewton meter. So this is the value. So now just if you want to represent this one in the frame, whatever we have considered earlier, see here, this is the frame we had considered. So the same values, this is A, this is B, this is C, this is D. So whatever we need to, if we want to represent this moment A to B, it is in the anti-clockwise direction. We will write here in the anti-clockwise direction. B to A also it is in the anti-clockwise direction, and B to C it is in the positive direction. Also C to B, here it also in the positive direction. C to D, here it is in anti-clockwise direction. Here also D to C, here it is in terms of anti-clockwise direction. So this is how we can analyze a portal frame which is subjected to the lateral sway with the help of Kanis method. So similarly, we shall see few more problems related to the sway analysis in the coming classes. Thank you.